Hello, my name is Julia Madsen, and here's my lab 4 oscillations for physics 20-11. Here's kind of our table of contents. We'll be first going through our introduction, then a motion analysis, our computational models, and then our graph of our predicted and our observed, and then any additional questions. So the formulas we were using is a formula K, which is our kinetic energy, which is 1/2 times the ball mass times the magnitude of the ball's velocity squared, then the change in K, which is K minus K initial, and then the potential energy for gravity, which is ball mass times gravity times the ball position in the y direction, then the change in the potential energy due to gravity, which is the potential energy due to gravity minus the initial energy due to gravity. Then the potential energy for springs, which is 1/2 times the spring constant, and then S squared. And then that is, the change in that is that minus its initial. And then our total energy is the kinetic energy plus the spring energy plus the potential energy due to gravity, and then our change in energy is the change in everything summed together. So those are the formulas we used. And then our motion analysis, so we pulled up the video in Tracker, and it was the guy pulling the spring mass and then oscillating in a circle. And so we set it up so that the origin was at the fixed point at the top, and then we calibrated it to be 0.7 meters as shown in the original video. So our computational model we made on GlowScript, and it shows the change in energy graphed for a computational model as it calculated everything. And so here's how we did the data for it, and then here in the bottom is what it looked like. And then our graph of our predicted versus our observed. So the blue line is the model and the red line is the experiment. As you can see, like, the x position changed over time to be a little more toward the origin and then trailed off, so it was going more towards the right direction. And then our experimental y position staggered up and down a lot more than our model did. So why weren't our predicted and observed the same? I would say this could be due to other factors such as air resistance. You know, he could have filmed it in a windy room. And then what would happen if we raised the floor so it might bounce sometimes? Well, if I go back to our graph, it might show that the bottom is more raised and it goes up higher because it has more force, because it has the contact force going against it for a certain time. And then what would happen if we made it swing like a pendulum? Well, the x position might change more than the y position, and it would change. It would look very similar on the graph, but the x position would change way more uniformly than it is. Thank you for watching, and I hope you all have a great day.